Hello everyone, myself Dr. Gomathi, Assistant Professor, Department of ECE, S.A. Engineering College. In this session, we are going to see about the subject called electromagnetics, which will be useful for the students who are preparing for the GATE exams as well as for the competitive exams. This is our institute vision and department vision, and this is our department mission and institute mission. So coming to the syllabus of electromagnetics, which deals with the very important concept called Maxwell's equation in differential form and point form, that is in integral form and point form, and the second module is of plane waves and its properties, and the third module is of transmission lines, which consist of S parameters, Smith chart, etc., and the fourth module is of rectangular and circular waveguides. So we will see one by one. So in this lecture, we are going to see about the very basics called as quantities. So what are quantities? Something which is measurable is called as quantities, whereas quantities are classified into two types. One is scalar and vector quantity. So scalar quantities are nothing but a quantity which has only magnitude is called as scalar quantity. Example is length, volume, area, etc. And vector quantities is nothing but a quantity which has both magnitude and direction is called as vector quantity. Example is displacement, velocity, force, etc. So how to represent a vector? As we discussed, vector is nothing but something which has, the quantity which has both magnitude and direction is called as vector. So vector can be represented by a directed line segment with some magnitude and direction. So this line segment which has a starting point called tail and the ending point called head. So simply a straight line cannot be considered as a vector. So magnitude, the straight line which has a magnitude A and B with some direction can be considered as a vector. So now we'll see the problems with respect to this vector representation. The first problem is obtain the unit vector in the direction from the origin towards the point 3, minus 3, minus 2 and find the position vector P. So the given question is find the unit vector. As we know, the formula to find the unit vector is vector divided by magnitude of that vector. So how to find this vector? So in order to find this vector, the starting, that is point is given P of 3, minus 3, 2 and which starts from the origin. So origin is the starting point and point P is the ending point. So by using these 2 points, we are going to find the distance vector OP, which is nothing but the point 3 minus the origin point 0 into AX, minus 3 minus 0 into AY, minus 2 minus 0 into AZ. So from these we can find the distance vector 3AX minus 3AY minus 2AZ. So 3 is the magnitude which travels in x direction, and minus 3 is the magnitude with respect to y direction, and minus 2 is the magnitude with respect to z direction. So after finding this unit vector, we are going to find the magnitude of that vector, which is nothing but root of 3 square minus 3 square minus 2 square, which is 4.69. Substitute both the values in this formula, which is unit vector a suffix op, O is the origin, P is that particular point, which is vector divided by magnitude of that vector, which is 3AX minus 3AY minus 2Z divided by the magnitude, which is nothing but 4.67. Dividing this 3AX divided by 4.69, we get 0.63 into AX minus 0.63 into AY minus 0.42 into AZ. This is the first problem. We will move on to the next problem. 2 points A of 2, 2, 1 and B of 3, minus 4, 2 are given in a Cartesian system. Obtain the distance vector from A to B and the unit vector. So the same problem, that is we are going to find the unit vector. So in the previous problem they are given as origin to the point. From the here in this problem they are given 2 points. The starting point is A and the ending point is B. So first of all write the given vector from these points. The A vector, which is 3 points are given 2, 2, 1. Since it is given in Cartesian coordinates, we are going to consider the variables as x, y and z. So 2 into AX plus 2 into AY plus AZ. The second point which is given as 3 into AZ minus 4 into AY plus 2 into AZ. So from these 2 points, find the distance vector, which is nothing but B minus A, which is 3 minus 2 into AX minus 4 plus 2 minus 2 into AY, 2 minus 1 into AZ. From this we find the distance vector, which is nothing but AZ minus 6 into AY plus AZ. From this find the magnitude of this distance vector AB, which is nothing but root of 1 square minus 6 square plus 1, which is 6.16. From this find the unit vector. The formula for unit vector is vector divided by magnitude of that vector. So substitute the vector value AX minus 6AY plus AZ divided by 6.16. Dividing these values, 1 divided by 6.16, which is 0.16, minus 6 divided by 6.16 minus 0.97, and then 1 divided by 6.16, 0.16 into AZ. Okay, this is our second problem. Now we'll move on to the next problem. If the vector A vector, which is equal to 10 into AX minus 4 into AY plus 6 into AZ, and the B vector, which is equal to 2 into AX plus AY. So what are the things we are going to find is, the first one is find the component of A vector along y direction. Second one is magnitude of 3A vector minus B vector, and third one is unit vector along A vector plus 2AB. So first we will find, the first question is find the component of A along the direction y. So from the given question, the magnitude of x is 10, the magnitude of y is minus 4, the magnitude of z is minus 6. The given question is find the component of A vector along AY. In the AY direction, the component is, which is nothing but minus 4. So the second question is magnitude of 3A minus B. So multiply 3 with A vector and then subtract with B. So the A vector value is given, the magnitude is nothing but 10 minus 4, 6. So multiply with 3, so 3 into 10, 30. 4 into 3 minus 12, 6 into 3 18, minus subtract this B vector. So directly we can subtract. So 30 minus 2 it is 28, minus 12 minus 1 it is minus 13, 18 minus 0 it is 18. So the value of 3A vector minus B vector is 28AX minus 13AY plus 18 into AZ. So next we will say find the, what is the magnitude of 3A minus B vector. So taking the square root, that is 28 root of 28 square minus 13 square plus 18 square, we get the magnitude of 3A vector minus B vector, which is nothing but 35.74. And the last question is A vector plus 2B vector. So multiply 2 with B vector. So multiplying 2 with B vector is 2 into 2 it is 4, 2 into 1 and then 2 into 0 0. So directly add these vector. 10 plus 4 it is 14, minus 4 plus 2 it is minus 2, 6 plus 0 it is C. Okay, and the last one is finding the magnitude of this for this particular A plus 2B. So finding the magnitude, root of 14 square minus 2 square plus 6 square, we get the answer as 15.36. So this is the given question. Find the component of A vector along y direction, magnitude of 3A minus B, which is nothing but 35.74, and the magnitude of A plus 2B, which is 15.36. And we'll move on to the next problem, very important question. A vector field is given as the F vector, which is equal to x square y x bar plus y z square y bar plus the function of x comma y comma z into z bar. What should be the function f of x comma y comma z so that the vector f is said to be solenoid? How to find the given f vector is solenoid? So we'll move on to the given function is f equal to x square y x bar plus y z square into y vector plus function of x comma y comma z into z vector. So now we will see whether the given f vector is solenoid or not. So in order to check the condition for solenoid, the divergence is del dot F equal to 0. Always the dot product is said to be divergence and the cross product is said to be curl. So del dot F vector equal to 0. So how to write this del? Dou by dou x plus dou by dou y plus dou by dou z equal to 0. So dou by dou x into what is the x vector magnitude of this x vector? It is x square y plus dou by dou y into with respect to y, it is y into z square. What is f of x comma y? It is not given, so write as directly. So dou by dou z of f of x comma y comma z, which is equal to 0. So differentiating this particular term, so dou by dou x of x square, which becomes 2xy plus differentiating the y term alone, dou by dou y of y z square, so y becomes 1, so z square. So this particular term we don't know, so entire term I am taking as f, so dou by dou z of f equal to 0. So from this I am considering only dou f, so all these dou x term will come this side, so dou f which is equal to minus 2xy minus z square into dou z. So from this, in order to find f, so I am going to integrate this, so integrating the entire part, integrating minus 2xy minus z square into dz. So after integrating this, I am getting as integrating this particular part, so I am getting as 2xyz minus x cube by 3. This is our answer, which is nothing but our first option, minus 2xyz minus x square by 3. The next problem is, what is the force experienced per unit length by the conductor carrying 5 amps current in the positive z direction, which is placed in the magnetic field with flux density B is equal to 3x bar plus 3y bar Tesla. So what is the given question? To find the force experienced per unit length. So in order to, these are the given 4 options as given, so directly we will move on to the problem. So the magnetic force, the formula to find the magnetic force, F for force and M for magnetic. The magnetic force, to find the magnetic force, the formula is IDL cross B. So cross is nothing but we are going to make a curl with respect to current and flux density. So the given current is nothing but, given the question, 5 amps flowing in positive z direction, so dz into the vector Az cross B is given, the magnetic flux is given in the question, which is 3x plus 3y bar. Substitute here, so multiplying these terms, Az into x bar, that is z into x, which gives y direction, so 3y, z into y, which gives the reverse direction, which is nothing but minus x, so minus 3x. So from this equation we can write as 5 into 3, which can be written as 15y, 5 into 3, which is given as 15x bar. So from this directly we can write as Fm divided by dx, that is the magnetic force with respect to z direction, it is given as 15y minus 15z bar. So this is the given, this is the answer we got, which is nothing but the second option, minus 15x plus 15y Newton per meter. We'll move on to the next question. The inductance of the long solenoid of the length 1000 millimeter wounded uniformly with 3000 turns on a cylindrical paper tube of 60 millimeter diameter is dash. The options are 3.2 millihenry, 3.2 microhenry, 32 millihenry, 3.2 henry. So we'll find what is the inductance of a long solenoid. So the inductance of the solenoid, since it is a direct question, we can substitute in the formula. The inductance of the solenoid L is nothing but mu n square A divided by L. So mu is nothing but permittivity of the material, mu naught into mu r, whereas mu naught, the formula for mu naught is 4 pi into 10 power minus 7, mu r is 1, so into N is given in the question 3000, so 3000 square into area, the formula for area is pi r square, so pi into r square, r is given in the question 30 into 10 power minus 3 the whole square divided by L is nothing but 1. So substituting all these value and then calculating, we get inductance L equal to 31.9 into 10 power minus 3 Henry, or 32, approximately we can write as 32 millihenry, which is nothing but the given question. The answer is, it is 32 millihenry, the third option. So we'll see the remaining lectures, remaining topics in the next lecture. Thank you.